In this video, we'll take a look at section 7.5, which is graphing f of x equal to a times x minus h squared plus k. Okay, now our first objective, we're going to take a look at graphs of f of x equal to ax squared. Now, before we get into those types of functions, let's go ahead and take a look at the parent graph, which is f of x equal to x squared. Now, when we have the function f of x equals x squared, this is a parabola shape. Now, with this parabola, this point that's in the very middle, this has a special name. This is called the vertex. And now, additionally, with parabolas, we have this vertical line. This is called the axis of symmetry. What that means is if you flip the graph about that line, you'll end up with the same graph. Now, the equation for the axis of symmetry, since this is a vertical line, this would be the equation x equals 0. However, that could change depending on the function that we have. Okay? And we'll go ahead and take a look at some of those types of problems. So now when we're taking a look at graphs of f of x equal to ax squared, now if our a is positive, so if a is greater than 0, what that indicates is the parabola opens up. So we'll have a parabola that opens upward. Now if a is less than 0, so if your a is negative, that means your parabola is going to be opening downward. I know we have two conditions here. If the absolute value of a is bigger than 1, the parabola is narrower than f of x equals x squared. If the absolute value of a is less than 1, the parabola is wider than f of x equals x squared. Let's take a look at an example. So graph by creating a table, find the vertex and axis of symmetry. Okay, so let's go ahead, let's create a table. Let's create an XY table. Now, first point that you want to find is the vertex. To find the vertex, you want to figure out what's going to make the x squared part of our function 0. What can I plug in for x squared to make it 0? Well, in this case, I could just plug in 0. This is going to give me my vertex. Okay? So I'm going to plug in 0 for my x. So now I have negative 1/3. Remember, f of x is just the same thing as y. So this function is really y equal to negative 1/3 x squared. Okay, so I'm plugging in 0 for my x. I end up with y is equal to negative 1/3 times 0 squared, which gives me negative 1/3 times 0, which is just 0. Okay. So that gives me my vertex. But now I want additional points. And now since we have these parabola shapes, we have this parabola shape, I want more than 2 points. Okay. So for example, if I plot my vertex, which is right there, the origin 0, 0, and if I plot one more point, this doesn't tell me what the parabola is going to look like. Because remember, we have like a curve shape for our parabola. Okay, so let's go ahead, let's find, say, 4 more points. Okay. Now, after you get the vertex out of the way, once you find the coordinates for the vertex, now we could just plug in any other number for x. Okay, so let's go ahead, plug in, say, I don't want to choose 1 because I'm going to end up with a fraction. How about if I choose, say, positive 3? So if I choose positive 3, I get y is equal to, I have negative 1/3 times 3 squared, which is going to give me negative 1/3 times 9, which is equal to negative 3. So that gives me another point that's in my graph. So I have 3, negative 3. Okay. Now I'm going to show you something pretty cool with this axis of symmetry. Now your axis of symmetry is always going to go through the vertex. So this is my axis of symmetry, this red line. Now I could use my axis of symmetry to find another point. Since it has to be symmetric about this line, Now, since this x-coordinate is 3 units away from my vertex, if I go 3 units in the other direction, my y-coordinate has to be the same, which puts me at -3, -3. And now I have another point. Now, if you actually check it, if I plugged in -3 for my x, you'll end up with -3 for your y. But I didn't actually have to plug it in because I used the axis of symmetry to figure out that other point. Okay. Now let's go ahead and figure out another point, another 2 points for our graph. Let's say if we plugged in, I guess we could use 6. So if I use x equals 6, now I have y is equal to, so I have y is equal to -1/3 times 6 raised to the second power. So this gives me -1/3. Just rewrite this. So this gives me -1/3 times 36, which gives me -12. Okay, so now I have another point. So I have the point 6, -12. Now -12 isn't going to be on here, so let's go ahead and approximate it to be about this right over here. And now since I have 6, -12, I could use my axis of symmetry again to find another point. So since this is 6 units away from my x-coordinate in the vertex, if I go 6 units in the other direction, my y-coordinate has to be the same, giving me -6, -6, 12 as another point. So now we have a good amount of points. Let's go ahead and connect them with the parabola shape, and we have our graph. Okay. Let's take a look at another problem. Notice how our parabola is opening downward, and that is because our a here is negative. And when we actually plotted our points, we can see that it's going to open downward. So let's take a look at another problem here. Give me 1 second. For some reason, it's not letting me get out of the equation editor, so let me try. Okay, there it goes. All right, now our next problem. Okay, so we want to graph by creating a table. This time we have f of x is equal to 3x squared. But remember, this is just the same as 3x, y equals 3x squared. Okay, now let's go ahead and create our table. So we have x, y. Now the very first point that I want is whatever's going to make the x squared part 0. Which in this case, very similar, it's going to be 0. Now before we start plotting points, let's go ahead, let's take a look at which way the parabola is going to open. So since my a is positive here, that means it's going to open upward. Okay. So when we create our table and we find our points, we have to make sure that our parabola is going to open up. Okay. So first point, if I choose 0 for my x, I get y is equal to 3 times 0 squared, which just gives me 0. Okay. So I have this point right over here. This is my vertex. My axis of symmetry has to go through my vertex. Let's go back up to the previous problem real quick. Let's label our vertex. So our vertex has the coordinates 0, 0. And then our axis of symmetry has the equation, remember since it's a vertical line, it's x equal to some number, and that number is x equals 0. Right. now let's go back to the next example. So we found our vertex and we drew our axis of symmetry. Now we could go ahead, pick some points, pick some values for x, and then figure out what y is equal to. Let's go ahead and plug in 1 for my x. I get y is equal to 3 times 1 squared. Well, 1 squared gives me 1. 3 times 1 gives me 3. So now I have an additional point. So I have the point 1 comma 3. And now if I use my axis of symmetry, since this was 1 unit away from our vertex, if I go 1 unit in the other direction, that puts me at negative 1 comma 3. Because remember, your y has to be the same. So now I have another point. So I have a total of 3 points now. Let's go ahead and figure out one more point. Well, let's go ahead and plug in 2 from our x. We have 3 times 2 raised to the second power, which gives me 3 times 4, which is 12. So now I have the point 2 comma 12, which will approximate about right over here. But now since 2 comma 12 is a point, if I go 2 units the other direction from my vertex, I get negative 2, 12 as another point. So now we have 5 points. We could go ahead and draw our parabola. And notice this time it's more narrow than the other one. And that's because our absolute value of a is bigger than 1. So now let's label our vertex, which is 0, 0. And our axis of symmetry is the line x equal to 0. Now let's take a look at other types of parabolas. So our next objective, we're going to look at the graphs of f of x equal to a times x minus h raised to the second power. Now the graph of f of x equal to a times x minus h raised to the second is the same shape as f of x equal to a times x squared, just shifted to the right h units. And then the graph of f of x equal to a times x plus h raised to the second is the same shape as f of x equal to a squared, just shifted to the left h units. Now the vertex in this situation is h comma 0, and the axis of symmetry is x equal to h. Okay. So let's take a look at this next problem. So graph by creating a table. Find the vertex and axis of symmetry. So we have f of x is equal to 1/2 times x minus 4 raised to the second power. Remember, this is very similar. I could just change f of x into a y. So I have y is equal to 1/2 times x minus 4 raised to the second. Well, let's go ahead and create our table. So we have an xy table. Now, very first point that we need to find is the vertex. To find the vertex, it's whatever makes the x squared part 0. So you have to figure out, okay, what can I plug in for my x in order for this to be 0? Well, if I plug in 4 for my x, I get 4 minus 4, which is 0. And I have 0 squared, which is 0, which is what I want. I want the squared part to be 0. That's going to help you find out what your vertex is. Okay, so now if I plug in 4 for my x, I get y is equal to 1/2 times 0 minus 0. I'm sorry, scratch that. I'm going to get 4 minus 4 and then raised to the second power. Well, 4 minus 4 gives me 0. So I have 1/2 times 0 raised to the second power, which is 0. And now 1/2 times 0 is 0. So I have the 0.40. This point over here is my vertex. And then I can draw my axis of symmetry. Remember, it always goes through the vertex. Okay. Now, over here, let's go ahead and just find 2 more points, because now we know what the shape of parabolas are. Okay. So let's go ahead and find another point. We have to choose a value for x and then figure out what our y is going to be equal to. So let's go ahead and choose 0 for our x. So if I plug in 0 for x, I get y is equal to 1/2 times 0 minus 4 squared. This is equal to 1/2 times, now 0 minus 4 gives me negative 4. But negative 4 raised to the second power gives me 16, positive 16. So I have 1/2 times 16, which is 8. So now I have another point. I have the point 0, 8. Okay. So 0, 8 is this point right over here. And now I could use my axis of symmetry to find another point. So how many units is this away from the vertex? It's 4 units. So if I go 4 units in the other direction, I'll end up with 8, 8. Because remember, your y-coordinate has to be the same. So I just used my axis of symmetry. I didn't have to plug anything in, and I found an additional point. Now let's go ahead and connect these 3 points with each other. Just be careful, it's not a V shape. It's more of like a U shape. It's a parabola. So let's go ahead and connect this with the U shape, and we get our graph. Let's take a look at another problem. So let's go ahead, let's label our vertex and axis of symmetry first. So my vertex, 4, 0, and then my axis of symmetry, it's that vertical line, so it's going to be x equal 2, and what is that x coordinate? It's 4. So my axis of symmetry here is x equal to 4. Now let's take a look at the next problem. So same type of problem. We're going to graph by creating a table. Let's go ahead and change our f of x into a y first, so it's something we're more comfortable with. So we have y is equal to negative 2 times x plus 3 squared. Notice how our a here is negative, which means our parabola is going to be opening downward. All right, well, let's go ahead, let's create our table. So we have x, y. Very first point I want to figure out is my vertex. So to find the vertex, it's whatever is going to make the squared part 0. So what can I plug in for x to have it as 0 squared? Well, I could plug in negative 3. Okay. So let's go ahead and plug in negative 3, and we'll figure out what our y is equal to. So I have negative 2 times negative 3 plus 3 squared. So this gives me negative 2 times 0, which is just equal to 0. So now I have my vertex, which is negative 3, 0. Which now I can draw my axis of symmetry. Okay, and now let's go ahead and find 2 more points. So let's go ahead, let's plug in a number for x. Let's say I plugged in 1. Let's figure out what y is equal to. So if I plug in, or let's plug in different value. Let's plug in something a little bit easier. Let's plug in 0. Okay. So if I plug in 0 for my x, I now have negative 2 times 0 plus 3 squared. Okay. This is going to give us a pretty large number. Let me stick with 1. Sorry about that. Let's plug in 1 for our x. Okay. So if I plug in 1, sorry, instead of positive 1, let's plug in negative 1. Okay. So if I plug in negative 1 for my x, I just want to get some small numbers for y, that way it'll fit on our graph. So if I plug in negative 1, I get negative 2 times, now negative 1 plus 3, that gives me positive 2, I have raised to the second power. So this gives me negative 2 times 4, which gives me negative 8. So now I have another point, negative 1 comma negative 8, which is this point right over here. And now I can use my axis of symmetry to find one more point. So since this is 2 units away from the vertex, if I go 2 units in the other direction, my y-coordinate should be the same. So that gives me the point negative 5, comma 8, comma negative 8. So now I have these 3 points. Let's go ahead and connect them with each other, and we have our graph. Okay. So our vertex in this problem, we have negative 3, 0, and then our axis of symmetry, it's the vertical line, x equal to negative 3. Now, our next objective, we're going to take a look at the graphs of f of x equal to a times x minus h squared and then plus k. Now, the graph of f of x equal to a times x minus h squared plus k is the same shape as f of x equal to a times x minus h squared, just shifted up k units. And then the graph of f of x equal to x minus h squared minus k is the same shape as f of x equal to a times x minus h squared, just shifted down k units. Now this time our vertex, the y-coordinate is being shifted, it's changing. So our vertex here is h comma k, and then the axis of symmetry is x equal to h, so that stays the same. It's still the x coordinate in your vertex. And now for a greater than 0, so if your a is greater than 0, k is the minimum function value, and for a less than 0, k is the maximum function value. So remember, when our a is bigger than 0, that means our parabola opens upward. And that point on the vertex, that y value in the vertex, this is your minimum function value. It's the lowest that that graph gets to. And now when a is less than 0, your parabola opens downward. So meaning that y-coordinate in the vertex is your maximum function value. So now, graph by creating a table, find the vertex and axis of symmetry, and the maximum or minimum function value. All right. So let's go ahead, let's change, sorry about that. So let's change g of x into a y. We have y is equal to x minus 1 squared and then minus 3. Okay. So first, let's figure out what our vertex is. So let's create our table. We have an xy. Now remember, to find your vertex, it's whatever's going to make this part 0. The whatever is being squared part, you want to make that 0. So you have to determine what can I plug in for my x in order for that to be 0. Well, I could plug in 1. So let's go ahead and plug in 1 for our x. We get y is equal to 1 minus 1 squared and then minus 3. Simplify, 1 minus 1 gives me 0. 0 raised to the second power gives me 0. So I have 0 minus 3, which is negative 3. So my vertex here is 1, negative 3. 1, negative 3, which is this point. Okay. Axis of symmetry goes through the vertex. So let's go ahead and draw that. Okay. And now let's find 2 more points. Okay. Well, let's go ahead, let's plug in, say, 2 for my x. Now I have y is equal to 2 minus 1 squared and then minus 3. 2 minus 1 gives me 1. 1 raised to the second power gives me 1. So I have 1 minus 3, which is negative 2. So I have the point 2, negative 2. And now I could use my axis of symmetry to find another point. So since this point is 1 unit away from the vertex, if I go 1 unit in the other direction, my y-coordinate has to be the same, giving me the point 0, negative 2. So now let's go ahead, connect them with each other, and we have our parabola. So vertex, let's label the vertex. So my vertex here is 1, negative 3. Axis of symmetry is x equal to 1. And now we have to determine if this is a maximum function value or a minimum function value. And that depends on the vertex. So let's take a look at the vertex. Since this is the lowest that this parabola gets to, this is a minimum function value. So we have a minimum function value. So we have a minimum function value of, and whatever our y-coordinate is in the vertex, which is negative 3. Let's take a look at one last problem. So a graph by creating a table, find the vertex and axis of symmetry, and the maximum or minimum function value. Okay, so first let's change t of x into y. So we have y is equal to 1/2 times x minus 3 squared, and then plus 5. Okay, so let's go ahead and create a table. First point we want to determine is the vertex. So you have to ask yourself, okay, what can I plug in for my x in order for this to be 0? I could plug in 3. So if I plug in 3 for my x, I get y is equal to 1/2 times 3 minus 3 squared, and then plus 5. So I have 1/2 times 3 minus 3 gives me 0. So I have 0 squared and then plus 5. Well, 1/2 times 0 gives me 0, which leaves me with 5. So I have the point 3, 5. That is my vertex. Let's draw our axis of symmetry, so that way we could use it to find an additional point. Well, now let's go ahead and pick another value for our x. Let's go ahead and pick, I don't know, let's say 4. So if I plug in 4 for my x, I get y is equal to 1/2 times 4 minus 3 squared, and then plus 5. If I plug in 4, I'm actually going to end up with a fraction. Let's change it into 5 instead. It'll make it a little bit easier when we're plotting. Give some more accurate graph. Okay, so let's plug in 5 instead. So we have 1/2 times 5 minus 3 squared, and then plus 5. So now we have 1/2 times 5 minus 3, which gives me 2. And I have raised to the second power, plus 5. So this gives me 1/2 times 4, and plus 5. 1/2 times 4 gives me 2. 2 plus 5 gives me 7. So I have the point 5, 7, which is this point over here. But now using my axis of symmetry, since 5, 7 is a point, if I go 2 units in the other direction, puts me at 1, 7. That would be another point. I have my 3 points. Let's go ahead and draw our parabola. And now we have our graph. So our vertex, I had 1, 7. Okay, so my vertex is 3, 5. Axis of symmetry is x equal to 3. And in this case, we do have a lowest point that this graph gets to, so which means we have a minimum value of, and then whatever our y coordinate was in the vertex, which is 5. So we have a min value of 5. All right. So that was it for section 7.5. If you have any questions, don't hesitate. Just email me and I'll help you out.